Alrighty. Well, today we are going to discuss multiplying multi-digit whole numbers and multiples of 10. We're going to use the place value chart to do this. We're going to think about the distributive property and the associative property. The distributive property is where we share out to other things, and the associative property is knowing that like 5 plus 2 is the same thing as 2 plus 5. Well, same with addition and multiplication, right? 5 times 2 is the same thing as 2 times 5. So the order or sequence of those doesn't matter or change things. The problem that we're going to start with today is 4 times 30. So 4 times 30 would be having 3 tens here, right? So we have our group of 3 tens. I'm going to switch out and grab my pen here. And if we had 4 times that, oops, that means I still have to get 1, 2, 3. So now I have 1, 2, I have 3 groups, and now I have 4 groups, right? And so it's just saying I have these 4 groups. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, when I have a group of 10, that means that they can move over to the hundreds place value. And I have 1 here. And so then I'm going to write down how many I have. I have 1, and then I have 2, and I have nothing here. So I'm going to go ahead and put that 0 placeholder. So 120. So 4 times 3, as you know, is 12. So 40 times 3, that makes sense that it would be 120. Okay, I'm going to go ahead and erase all of this. And we'll try another one, okay? So if I did 40 times 30, it's still kind of the same concept in so much as we can do 4 times 3 and then add those double zeros in. So when I want to think about this one, what I actually want to think about is, let me make sure, okay, nope, I don't have a pen. I need you to be on the pen. 40 times 30. Really what I focus on here is this 4 and this 3, and I know 4 times 3 is always 12, and then I count the number of zeros that I have in the factors because that's how many zeros I'll have in the product. Remember, these are called factors, right? They're the numbers that we multiply by each other, and this is called the product. And so those vocabulary terms become really important here, factors versus product, okay? So if I were doing 40 times 30, this is what I would get. Now, if I took this a step further and I did 40 times 300, well, interestingly enough, 4 times 3 is still 12, but now I have 3 zeros. So I'm just going to add those 3 zeros on the back side here. It works every time as long as there's zeros back there. It's not going to change anything. So my product is 12,000. So just a way to quickly multiply with units of tens. Okay, so we're going to come back to here, and I'm going to model what would happen if we did 60 times 5. Well, 60 is 6 tens. 1, 2, 3, 4, 5, 6. And we need 5 copies of that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I know you love hearing me count. 5, 6. I have 1, 2, 3, 4 copies. I need 2 more copies of these. So I'm just making each of those copies, right? When I think about copies, that's multiplication. How many times do I make that? So I made 5 copies. And then what we can think about is grouping those into our units of 10, right? And because of how I organize it, this row and this row, these two combined, and they make 100, right? This row and this row, these two can combined, and they make 100. This row and this row, they can combine and make 100. So now I have 300. And then I have 1, 2, 3, 4, 5, 6. So 6 tens. So now I can see that I've got 360. Well, gosh, what's 6 times 5 or 5 times 6? Did I do this correctly? 1, 2, 3, 4, 5, 6. Oh, I did 6 copies instead. So this would be 60 times 6. If I did 5 copies, I would have 1 less. I didn't realize I did 6 copies. Oopsie. Let me grab my eraser here. So it would be 1 less. Choop, 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 choop. Choop. And that one wouldn't be able to move over. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we'd have 39. Okay, so I was just thinking about those copies. To be honest, for me, always, I think the traditional algorithm is a lot faster. Let me clear this screen, just because, I don't know, it just always is for me. It was how I learned math. I know it's how your parents learned math. So if I did 60 times 5, for me, this is, I look at it and I go, oh, 6 times 5 is 30, and I add that extra 0 on the back, so 300, and I'm done, which to me is a lot faster than drawing dots. And 60 times 50, again, when I have these zeros on the back, I just know I'm going to write down 2 zeros, and then I'm going to do 6 times 5, and 5 times 6 is 30, so 3,000, and I'm done. Okay, and I could do this with any multiples that are like that. It doesn't matter if it's hundreds or tens or thousands. If that 0 is in there in that place value, then I'm going to move on with it. Okay, now if I get something a little bit more complicated, for example, 451 times 8, I'm going to actually do it on a new board. 451 times 8. Now, again, for me, I just want to use the traditional algorithm because I want to do things really as quickly and as fast as I can. Partial products is another one that I think works really well for you guys. So I'm going to put my 8 out here, my 4, my 5, and my 1. So 8 times 1 is 8. 8 times 5 is 40. 8 times, and then I'm going to do 8 times 4. And so I'm going to do it over here as well. And so when I do that traditional algorithm, right, I get 8, I get a 0, I carry my 4, I get 32, 36. Okay, so 32. Sorry, I didn't put that in there. And then I just add up these numbers. So, but I have to think about my place value. And so this 4 right here is going to bump over to here. I get 3608. What do you know? It's the exact same number. And so to me, traditional algorithm or this place partial products are 2 of the easiest ways. Now I'm going to tell you, in your books, they're going to do something like asking you, think 23 ones plus 2/10 and things of that nature. Just solve the problem, okay? However is best for you. If you like traditional algorithm, use traditional. If you like partial products, use partial products. Our goal by the end of 5th grade is to be where we are not dependent upon something of this nature, and we are much more, oops, I got lots of errors there, much more able to do it with just our standard traditional algorithm. And so if we're still using this model, we need to be working towards that traditional algorithm.